Completely broken. I'm not fucking around. Are you ready? I'm about to launch Asterisk. It should look just like it looks always when you load up into a game with the items on the bottom and then stars in the background. Are you ready? Three, two, one. This is what the game looks like now. This is permanent. Let me try zooming the camera in and out. It's beautiful. This is exactly what you want out of a video game. The gameplay is impeccable, and I am pleasantly surprised. I'm there's a lot of it's. You just saw the player scroll by. It's an action game now. Um, it's a very it's a psychedelic game, and it's just always gonna look like this now. This is permanent. Get used to the new Asterisk. I'm shipping this. This is how you play. It's kind of entertaining to look at. Just this kind of like zone out to just this flickering. Um, it's going to take a second for me to explain why it looks like this. Computers are really dumb and they can only represent binary numbers. Or sorry, like the memory in a computer like is a bunch of binary numbers. I don't mean like the literal computer is numbers because numbers aren't a real thing. This is an abstract concept. I mean literally that if you were to take the RAM that's in your computer, how it remembers, like the chip that it remembers stuff on, and you zoomed really far into the wafer or just like the shit that's on the memory chip in your computer, like super zoomed in, like a microscope super far, you would see these little structures, right? Where wires, just a few simple wires are put into this little cell and it's literally like flipped on or off. It has electrical charge or it doesn't. That's what I mean when I say there can only be a 0 or 1 in the computer. Is literally like physically, it's just like saying this Costco membership card can either be flipped this way or this way. Like physically, there's a physical analog for this conceptual idea of 1 or a 0. It's just like, is the electric charge, like, is it charged or not charged? Now this begs the question, right? Because sometimes we want to say that the player is like zero point 0.5 meters to the right. You know what I mean? And so all of the nerds, they got together in a gigantic consortium called IEEE, Advancing Technology for Humanity. This global network of nerds created what's called the IEEE Floating Point Standard. And this is just a document that describes a way of using those little physical RAM bits and pieces to approximate a floating point number, or a number that really is just, it's a fraction, right? Like a way to represent fractional numbers and to add and subtract and multiply math on them inside of the computer. And they basically take this binary number, right, which computers can represent in the little physical RAM, like up or down, and they just say like, okay, for every 32 bits, right? The first bit, if it's like a 1, it's a positive number, 0, it's a negative number. I don't actually know if that's the orientation, but you get the idea. And then we have an exponent and then a fancy word called a mantissa. See, they like to use confusing language to make it so it's harder to get into as a field. And that way they make more money because then it's harder to become a smart computer scientist. Economics of scarcity. She sells shells by the seashore. You know that like rap?
On the seashore, but the value of these shells will fall.
I don't remember what I was talking about. Oh yeah, mantissa, what it actually means. So if you paid attention at all in science class, you know that you can use these things called scientific numbers, like 3.14 times 10 to the 5. And a scientific number really is two components to it. It has like the fractional part, and then it has the part that tells you how big the number is. As you can guess, the exponent, this is a scientific number in binary form, and the exponent is just like the number 6 in binary form. And then the mantissa is just all of these digits, right? But the decimal point actually comes before them all. And so it's pretty simple, right? However, right? So this can encode very big exponents. With 8 bits, you can store 255 values. 10 to the 255 is pretty gigantic. Although this exponent isn't base 2 because, binary. The mantissa can only store 23 bits of information. Now, what both of those limits mean is that your decimal point numbers, even though they can be arbitrarily big, like that you can store like this number in a floating point number on a computer as defined by the IEEE consortium of nerds. Like even this big if you want, I'm not one to judge, because how many zeros there are is just one number saying how many zeros there are. You get what I'm cooking? I wanted to make a joke and I googled Dwayne the Rock Johnson and all that comes up is like pictures of like people on rocks or something. Like I don't even, it's because it's all copyright free so they can't show him. I just wanted to say, can you smell what the rock is cooking? Anyways, there's no limit to how big the number can be, but there is a limit to how many of these digits of detail there can be. And the astute viewer will have noticed, right? As the numbers get bigger, there's less and less. You don't have a room to like put numbers here in the beginning, right? Because if all of your mantissa, if all of your scientific notation, if all of those digits are at the end here, then there's no more left at the beginning of the number, which means that like at distances of 1 to 3 meters, like the information gets lost. So you see the player like snapping around in 3-meter increments as the numbers get bigger. Now, this is not a practical problem for even most like big games where it's like 1,000,000 meters, right? Even that number is not really too big. But actually, because of the way physics engines work, they often take a player position of, let's say, like 500 meters and like multiply it really big, like 100,000, and then divide it back down again, just because of how the physics like process is working. And so at about 10,000 units away from the origin, everything shifts from doubles to floats. Sorry, I just used 2 words and then explained it. So this is a float, and then a double is like double the size, 64 bits. Wait, sorry, that wasn't even true. I just had like a stroke or something. At around 10,000 units, shit starts to break down, and so you use twice this number of bits in the physics and the gameplay. But when you render to the screen, because data matters a lot on the graphics card on your computer, you need to send it in like 32 bits. And so anyways, the drawing library I'm using to draw all the stars and sprites expects something that's 32 bits big. But the physics and the gameplay needs to be done in 64 bits. You know what I'm saying? That is like, it's like twice the size, you know? And so today, part of the work I did was taking the drawing code and having all of it to be done in this 64-bit really big space. And then when it sends it back to the GPU, it casts it down to the smaller version. And then, you know, Bob's your uncle, we're done. I seem to have made a mistake somewhere in the data. Because what the GPU sees is just a list of numbers that you pass to it. You know, what's called like a buffer, or just like a bunch of numbers back to back with no real description or clarification. And it expects each of these numbers to take up a certain amount of bits. You know what I'm saying? Like it expects each of these numbers to correspond to these bits in a stream of bits, zeros or ones. And so because the graphics card expects things to be 32 bits, but I just like edited all the drawing code to send things in 64 bits, it's just way too much information for what it's expecting somewhere in the code. So now everything's broken. I'm going to be doing my work to fix it tomorrow, but I think it's going to be tricky. It's going to be tricky. I might have to go back in time and roll back these changes if it's like too complicated, you know? Anyways, that's all I got for you guys today. Make sure to like and subscribe. Play the unbroken version of the game for free in the link in the description. Make sure to hit that bell.